A steel wire is drawn from an initial diameter of 14 mm to a final diameter of 9 mm at a speed of 2 meter per second. The half cone angle of the die is 45 degrees and the coefficient of friction at the job die interface is 0.3. Initial yield strength and final yield strength of the specimen are given by 200 MPa and 300 MPa respectively. Assuming a linear stress strain relationship for the material and no back tension is applied, determine the true drawing force required. Here the options are 8 kN, 16 kN, 32 and 40 kN. First write down the given data here. Initial diameter is equal to 14 mm and final diameter is equal to 9 mm, and here the final velocity, that is velocity at the end of the process, is equal to 2 meter per second, and half cone angle is equal to 45 degrees, and coefficient of friction between the die interface is 0.3, and final yield strength is equal to 200 megapascal, and initial yield strength is equal to 300 megapascal. Sorry, here initial is 200 and final is 300 megapascal. So here we will have to find out the average yield stress, because we have two stresses here. One is at the final stage and one is at the initial stage. So the stress varies linearly with strain. That means here a linear stress strain relationship is assumed, so that the average yield stress is equal to sigma yf plus sigma yi by 2, which is equal to 250 megapascals. So here, since the no back force is applied and back force is 0, so in this case the drawing force is given by sigma xf into af, where sigma xf comes from the equation sigma y into pi by pi minus 1 into 1 minus df by di whole power of 2 into pi minus 1, where here pi is equal to 1 plus mu by tan alpha and is equal to 1 plus 0.3 by tan 45, so which is equal to 1.3. Now substitute all these values in the sigma xf. We already know df and da, final diameter and initial diameter, and here pi is equal to 1.3, and sigma y is the average yield stress, that is 250 megapascal, and here the final value of the sigma xf is equal to 252.25 megapascal. So now substitute all these values again in the force, that is F is equal 252.2 into the final area of the wire and is equal to 16 kilonewton. So this is the required force is 16 kilonewton, and in the option the correct option is B. B is the right answer. 1 unit of end product P, 2 A's, 3 B's and 4 C's are required. Each A requires 3 M's and 4 N's. 1 unit of B requires 4 C's and 55 D's. If 40 B's are needed and on the hand there are 50 B's, how many more C's are needed? Here the options are 440, 480, 640 and 200. So coming to the solution, here we need 40 P's, but each P requires 2 A's, 3 B's. Let us say 2 A's, 3 B's and 4 C's. So here again each A requires 3 M's and 4 N's. But there is no need to consider M's and N's, but we require here how many remaining C's. So here again 1 unit of B requires 4 C's and 5 D's. So from this we need 40 into 4, that is 160 C's, and from this we need 40 into 3 into 4, that is around 480 C's. So here the total number of C's are there. C is equal to 480 plus 160. So 640 required. But we have already 50 B's on hand. That means, so how many number of C's are on hand? C's on hand is equal to 3 into, sorry, 50 into 4, that is 200. Therefore, the required number of C's are C's is equal to 640 minus 200, which is equal to 440. So the total number of C's required is 440, and in the option, the correct option is A. A is the right answer. And standard deviation of demand distribution of an inventory items are 70 units per day and 15 units per day. The lead time and service constant for a 99% confidence level are 10 days and 2.33 respectively. Find out the buffer stock. Here the options are 28.5 units, 18.5 units, 110.5 units, and 55.25 units. Here let us say here the average demand is given by 70 units per day, and here average standard deviation of demand distribution is given by, let us say, S is equal to 15 units per day, and service constant and lead time for the constant for a 99% confidence level are 10 days, and let us say lead time is 10 days, and the service constant K is equal 2.33. So now here we will have to find out the buffer stock, and buffer stock is given by Ks root L, where K is the constant, service constant, and L is the lead time, and S is the standard deviation of the demand distribution. Here these are the values. K is 2.33 into 15 into root of 10 and is equal to 110.5 units. So in the option, the correct option is C. C is the right answer. In a telephone booth, the arrival rate of phone calls is 1 by 12 per minute, and length of phone call has a mean of 3 minutes. By considering the assumptions of a birth and death model of queuing system, find the traffic intensity. Here the options are 4, 2, 0.25 and 0.5. Here coming to the solution, let us say the lambda is the mean arrival rate, that is 1 by 12 per minute, and the length of the phone call has a mean of 3 minutes. Let us say the service time is, mean of service time is 3 minutes per call. So that means service rate of the call is equal to service rate of the call, let us say that is R is equal to 1 by 3 per minute. So according to the birth and death model of queuing system, the traffic intensity is given by the ratio of arrival rate to the service rate, so which is equal to 1 by 12 to 1 by 3 and is equal to 1 by 4. So here the traffic intensity is 0.25, and in the option the correct option is C. C is the right answer.